Hello students, welcome back to my channel Explore Physics, Let's Explore. In the previous class, I've solved numerical problems based on series combination. Now I'm going to solve the numerical problems based on parallel combination. This side of the board, you're going to see the numerical problems, and here I'm going to solve the problems. So without further delay, let's start the class. The first question is, calculate the equivalent resistance when two resistances of 3 ohms and 6 ohms are connected in parallel. Simple question. Always remember that in parallel combination, V or the potential difference remains the same, whereas I varies. I is different for different resistors, but the potential difference across the ends of 6 ohm in this example and 3 ohm will be the same. So potential difference remains the same in parallel, but I varies or current varies. This is the key rule to solve the numerical problems based on parallel combination. So the first question, in the first question it is given that two resistances. So R1 is given to you as 3 ohm and R2 I think is given to you as 6 ohms. So what will be R? They are connected in parallel. So what will be R? Total resistance. It will be equal to 1 upon 3 plus 1 upon 6 equals to 6. So here 2 plus 1 or equals to 2 plus 1, 3 by 6. So therefore, because 1 upon R is equal to 3 by 6, so R will be equal to 6 by the 3 reciprocal of that. So is equal to 2 ohms. So what will be the equivalent resistance of the circuit? 2 ohms. That is the first question. Remember, V remains the same, I varies in parallel combination. Let's start the second question. So the second question says, a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then what will be the ratio of R by R dash? So you have been given one wire of resistance R and it's cut into 5 equal parts. I have told that the new resistance is R dash. Then you have to find R upon R dash. This is what you have to do. So 1 upon R dash, that is the new resistance they have told, is equal to, when they all are connected in parallel, so one part with R by 5 resistance, then the next part 1 upon R by 5, then the next part 1 upon R by 5, then the next fourth part 1 upon R by 5, and the fifth part also 1 upon R by 5. 1, 2, 3, 4, 5. So what will be the total? It will be 1 upon R by 5 means 5 upon R plus 5 upon R plus one more time 5 upon R, one more time 5 upon R plus one more time 5 upon R. So 5 times 1, 2, 3, 4, 5. So that is 1 upon R dash and equals to 1, 2, 3, 4, 5, 5, 10, 15, 20, 25. 25 by R. Therefore, 1 upon R is equal to 25 by R, or that implies, if I am going to inverse it, so R dash will be equal to R upon 25, or R dash by R upon R dash, you have to find R upon R dash will be equal to R upon R dash. This R dash will go down and here it is 25. So here R by R dash will be equal to 25. So one wire cut into 5 equal parts. All these 5 resistors are connected in parallel. So we have to use the same formula which we deduce, that 1 upon R is equal to 1 upon R1 plus 1 upon R2, like this 5 times. So 1 upon R by 5, 5 times we have written. So it is 1 upon r dash is equal to 25 by r. 1 upon r dash is equal to 25 by r. So r dash is equal to r by 25. From here, r upon r dash is equal to 25. This is the solution for second numerical problem based on parallel combination. I hope it's clear to you. Please keep on practicing the numerical problems, children. As you practice, you will be more and more perfect. Then there is no looking back. We'll start with the third question now and see what does it say. So I'm going to take the third question now. How many 176 ohm resistors in parallel are required to carry 5 amperes on 220 volt lines? So how many 176 resistors? So each resistor is of 176 ohm. You have to find how many, means number you have to find, are required. They are all connected in parallel, are required to carry. I is given as 5 amperes on a 220 volt line. V is given as 220 volts. Okay. So how many 176 resistors are required? The number they know, so that it can carry 5 ampere current and the potential difference is already known to you. So we should know the total resistance of the system will be equal to R is equal to V by I. So V is equal to as 220, I is 5. So 5 4s are 20 and 5 4s are 20 again. So 44 ohms. So the equivalent resistance of the circuit will be 44 ohm. So say we need say the number is X. Means we have X 176 resistors are connected in parallel. So this already they know that 1 upon R is equal to 1 upon R1 plus 1 upon R2. This is X times. This is X times. We don't know what is X. Okay, the number we have to find. This we already know, which is equal to 1 upon 44 equals to 1 upon R1 is 1 upon 76 plus 1 upon 176. This X times these many numbers. Okay. So what will happen, or I can also write it as 1 plus 1 plus 1. So it will be equal to X upon 176 times, because 1 upon 176 will be X number of times. So therefore 1 upon 44 is equal to X upon 176. That implies X is equal to 176 by 44. 4 4s are 16, 6 1 carry 4, 16 70. So this is 4 times. So 4 numbers. Got it? 176 by 44 is 4. So we need 4 176 resistances to carry 5 ampere ohms and the potential difference is 220 volts. So what is the number required? 4. 4 is the number required to carry these resistances. Yeah. So that's all for the day. We have solved the numerical problems based on parallel combination. As I told you, please keep on practicing and do subscribe and like my channel if you like the content. Till then, stay safe, stay healthy, and a very big thank you to you all. Bye-bye.